initial value theorem. Initial x of 0 is the initial value of the signal x of n. Okay, so that we can write like limit n tends to 0 x of n. Okay, so x of 0 is the initial value, starting value of the signal x of n in time domain. That is equal to limit z tends to infinite x of z, where x of z is the z transform pair of the signal x of n. So that means initial value of the signal we can calculate either from the time domain or from the z domain. Okay, so if we know x of z, that again we have to substitute z to be infinite. Okay. Similarly, final value theorem. Final value theorem. That is x of infinite. That means in time domain, what is the value of the signal at n is equal to infinite? Okay, at n is equal to infinite, that is x of infinite. That means limit n tends to infinite x of n is equal to limit z tends to 1. Okay, it is not 0, it is 1. Whereas in the Laplace transform, we would have written as a 0, but here in case of z transform, for a final value theorem in z domain, z tends to 1. Okay. Again, z minus 1 multiplied with x of z. Okay, so in the first case, we are not using anything different, but in the second case, we are multiplying the x of z with z minus 1, and also the limit is not going to 0, but it is going to 1. Okay, so now we'll solve one problem based on this. Find the final value of the given x of z. Find final value, that is x of infinite of x of z. Okay, okay, so now we are given with x of z, that x of z value is z plus 1 divided by 3 into z minus 1 into z plus 0.9. Okay, so x of infinite. Okay, just now we have seen the formula. X of infinite means limit n tends to infinite x of n is equal to limit z tends to 1 z minus 1 multiplied with x of z. Okay, so x of infinite limit z tends to 1 z minus 1, then what is x of z? X of z is already given in the problem. Okay, so z plus 1 divided by 3 into z minus 1 z plus 0.9. So now z minus 1 z minus 1 cancel, then substitute z is equal to 1 in this expression. So 1 plus 1 3, 1 plus 0.9. Okay, so finally 0.35 is the answer. Next, inverse z transform. That means once if you are given with x of z, then how to calculate, okay, x of n. Okay, and also we know that x of z will be given along with ROC. Okay, so x of z with ROC again, because ROC will decide the signal whether it is going towards right or left. So now the question is find the inverse z transform of given x of z. Okay, find the inverse z transform of x of z is equal to 1 by 1 minus 1.5 z inverse plus 0.5 z power minus 2. ROC is mod z greater than 1. You see here everything is given in terms of z with the negative power. Either we can operate with the negative power or with the positive power. Okay, no problem. Both are okay. So now say now we'll convert this to the positive power. That means this will become like z square minus z square 1.5 z plus zero point 0.5. Okay, both are the same expression. Okay, so again, if you calculate the factors for the denominator, that we can write like z minus zero point 0.5 z minus 1. Okay, and we know that this can be splitted with the help of the partial fraction technique, that is a divided by z minus zero point 0.5 plus b divided by z minus 1. Okay, already we have seen how to identify a and b very simply. Suppose if it is in a simple format, okay, directly we can identify what is a and b. Okay, that and all already we have seen. So now directly I'll write, so x of z is at by z minus zero point 0.5 z minus 1 is equal to the a value is minus 1. Okay, so that means minus 1 divided by z minus zero point 0.5, b value is 2, 2 divided by z minus 1. Okay, so now what is the ROC? ROC mod z is greater than 1. Okay, so ROC is very, very important because based on the ROC, the result will vary. So just now we'll draw the ROC diagram. Okay, this is the circle with the radius of zero point 0.5. Okay, circle with the radius of zero point 0.5. And another one is circle with the radius of 1. Another circle with the radius of 1. Okay. Now, where is the ROC? Mod Z is greater than 1. That means ROC is outside the unit circle. Okay, so this is the region of convergence. Region of convergence. Okay, so that means what is the poles of the first function? Okay, that is for this first function, the pole is z equal to zero point 0.5. Okay, so z equal to zero point 0.5. With respect to z equal to zero point 0.5, the ROC is on the right side. Okay, with respect to the pole z equal to zero point 0.5, the ROC is on the right side. Okay, similarly, what is the pole of the second transfer function? That is z equal to 1. And again, with respect to z equal to 1, okay, so z equal to 1 is the unit circle. That okay, with respect to z equal to 1, where is the ROC? Okay, ROC is present on the right side. Okay, ROC is present on the right side. And also we know that already if ROC is present on the right side, okay, it's not right side. Again, we are using the wrong notation here. Okay, the right side, left side is only applicable for Laplace transform. Okay, so here ROC is outside the unit circle. So with respect to z equal to zero point 0.5, where is the ROC? Whether ROC is outside the circle or inside the circle? Okay, it is outside. Okay, outside the circle. Okay, outside the circle 0.5. Again, with respect to the circle z equal to 1, where is the ROC? That is also present outside. Okay, again, we know that once if ROC is on the outside the circle, definitely the signal is right-sided signal. Okay, definitely the signal is right-sided signal. Okay, so again, we have to write the inverse Z transform for this with the help of the right-sided signal. Okay, what is that? Z divided by z minus zero point 0.5 z minus 1 is equal to minus 1 divided by z minus zero point 0.5 plus 2 divided by z minus 1. We know that minus 1 so We made some mistake here. Okay, so instead of z square here z is there. That means the one more z that is present here, we have to take it here. Okay, that means here z square. Okay, directly don't apply the partial fraction directly. First of all, take the z down. Okay, that means uh, you write x of z divided by z. Okay, then write the rest of the things here. That means you will be getting z here because one z will go down. Okay, so then z minus zero point 0.5 into z minus 1. Okay, for this you take the partial fraction. Okay, why again we are taking the z this side, one z this side? Okay, because finally here we'll be getting some number. Okay, say for example you are getting, say for example a is 1. Okay, it may be any number, but for this we cannot take directly the inverse z transform, because whenever we are with the z positive power, definitely in the numerator we should have z. Okay, z by z minus a format. That's why we are taking one z before applying the one z to the left hand side before applying the partial fraction technique. Okay, so always whenever you are operating with the positive power of z, always you have to take one z downside. Yeah. Okay, so then that means again, um, this is x of z divided by z is equal to minus 1 divided by z minus zero point 0.5 plus 2 divided by z minus 1. Okay, finally we can take that z that side, that is minus z divided by z minus zero point 0.5 plus 2 into z divided by z minus 1. Okay, so just now we have seen the ROC is on the outside the circle. That means right sided signal. Okay, so this we can write like minus. Okay, because already minus is there. Okay, then what is the inverse is a transform of this one, that is zero point 0.5 whole power n un. Again this is 2 multiplied with z by z minus 1. That means simply u of n. Okay, simply u of n. Okay, so finally the answer is minus zero point 0.5 whole power n u of n plus 2 into u of n.